Earth is approximately 4.5 billion years old, formed from the same cloud of dust and gas that created the sun and the rest of the solar system. Over geological time, gravity, internal heat, and solar energy transformed Earth into a dynamic planet with continents, oceans, and an atmosphere. Earth is the only known planet where liquid water exists stably on the surface, supported by a finely balanced atmosphere and active interior. Beneath the crust, internal heat drives tectonic movement, volcanoes, earthquakes, and a magnetic field that protects the planet. Yet across Earth, natural forces operate at extreme limits. Temperatures that melt rock, pressures that reshape matter, and landscapes pushed to physical boundaries. So how extreme can a planet become before that balance is lost? Today's topic is Earth at its limits. How extreme can a planet become? Before we begin, if you enjoy in-depth documentary-style explorations of our world, consider subscribing to WonderDoc Studio for more science-based stories. In some regions of Earth, heat becomes the dominant force shaping the environment, pushing surface temperatures to the highest levels the planet can sustain. In arid zones near the equator, intense solar radiation strikes the ground directly, raising land surface temperatures beyond 70 degrees Celsius. At these levels, moisture evaporates almost instantly, and exposed rock expands and contracts daily, slowly breaking into sand. Extreme heat alters atmospheric behavior by creating powerful rising air currents that influence global wind circulation. Over time, repeated heating weakens rock structures, accelerates erosion, and limits the types of organisms that can survive. Life in these regions relies on extreme heat tolerance, water conservation, and nocturnal activity to avoid lethal exposure. Why does Earth allow such heat without triggering a runaway climate collapse? Satellites, rather than ground instruments, record many of the highest temperatures because equipment cannot endure prolonged exposure. These regions reveal the upper thermal boundary of Earth's surface environment. At the opposite extreme, Earth's coldest regions exist in a state where energy moves slowly and change occurs over immense timescales. In Antarctica, temperatures have fallen below -80 degrees Celsius, cold enough to remove moisture directly from the air. Ice sheets here grow several kilometers thick, pressing down on the crust and subtly reshaping the planet beneath them. Extreme cold slows chemical reactions, preserves ancient atmospheres in trapped air bubbles, and locks fresh water away for thousands of years. The weight of ice influences sea levels globally, while its bright surface reflects solar radiation back into space, helping regulate Earth's temperature. Nearly 70% of the planet's fresh water is stored in frozen form. How cold can Earth become before its systems stop functioning altogether? Despite the extreme temperatures, glaciers still flow, rocks still fracture, and microbial life survives in hidden pockets. These frozen landscapes define the lower thermal limits of Earth's active surface and reveal how cold can coexist with planetary stability. From the valleys to the sky, Earth's mountains rise as titanic guardians of the land. The Himalayas, with peaks piercing the clouds, are still growing, pushed upwards by the collision of tectonic plates. Have you ever wondered why mountains keep growing even after millions of years? It's the unstoppable force of shifting plates beneath our feet. Atop these dizzying heights, the air thins, temperatures drop, and life struggles to survive. Did you know climbers can suffer altitude sickness just a few thousand meters above sea level? Mount Everest, the planet's tallest peak, reaches over 8,000 meters. Yet it's only a fraction of the immense stress these mountains endure. Avalanches, landslides, and relentless wind sculpt these giants continuously, carving dramatic cliffs and jagged ridges. Imagine the energy it takes to move that much rock. Even the most robust species, including humans, face extreme challenges at these altitudes, battling oxygen scarcity and freezing temperatures. These mountains stand not only as physical monuments, but as symbols of Earth's raw power, resilience, and the eternal struggle between land and sky. Beneath the ocean's surface lies a world where pressure reaches unimaginable extremes. In the Mariana Trench, the deepest known point on Earth, the weight of thousands of meters of water bears down relentlessly. Can you imagine being squeezed by the weight of 50 jumbo jets stacked on top of you? That's the kind of pressure found here. Life here defies expectations. Strange, glowing creatures with flexible bodies endure what would instantly obliterate surface life. Some even have transparent skin to survive in total darkness. Even human technology struggles to venture these depths, requiring submarines built like underwater tanks to resist the crushing force above. Geologists probe these trenches to understand tectonic movements and the creation of Earth's hidden landscapes. Did you know that deep-sea trenches help regulate Earth's water and mineral cycles? The pressure shapes not only the organisms, but also the chemistry of the oceans, influencing minerals, gases, and even global circulation patterns. In these crushing depths, Earth reveals a hidden limit, a realm where survival is a miracle and the planet's immense power is tangible. Beneath the surface, Earth hides a seething power, molten rock ready to burst forth in fiery displays. Volcanoes are nature's pressure valves, releasing heat and gases from deep within the planet. Did you know some eruptions can blast lava over 60 kilometers per hour? From the violent eruptions of Mount Vesuvius to the flowing rivers of lava in Hawaii, these extremes shape the land in dramatic ways. Volcanic ash can travel thousands of kilometers, darkening skies and even affecting global climate. Imagine the sky turning gray far from the volcano itself. Some volcanoes lie dormant for centuries, then awaken suddenly, reminding us of Earth's unpredictable temperament. Volcanic soils, despite the danger, are incredibly fertile, supporting lush forests and thriving civilizations. Isn't it amazing that destruction and life are so closely connected? Scientists study volcanic activity to predict eruptions and understand how the planet releases energy from its fiery core. Fire from below is both a threat and a gift, showing the extremes of Earth's energy, where creation and devastation are two sides of the same coin. Rivers carve their way through continents, shaping mountains, valleys, and civilizations over millennia. Some rivers, like the Amazon or the Congo, carry enough water to fill entire oceans, demonstrating the unstoppable force of flowing water. Have you ever imagined the sheer energy of a river in flood, moving boulders and reshaping landscapes in days? That's nature at its most dynamic. Rivers transport nutrients and sediments, sustaining ecosystems far from their source, from forests to farmlands. Mighty rivers also power human civilizations, providing water, transport, and energy, yet they remind us of nature's unpredictability. During monsoons, rivers can swell beyond their banks, turning fertile plains into temporary seas of rushing water. Geologists study river patterns to understand erosion, sedimentation, and even past climates, reading the Earth's story in the water's path. In their strongest moments, rivers are both creators and destroyers, a testament to the relentless force of moving water. From scorching deserts to icy wilderness, we've witnessed Earth at its most extreme. We've climbed towering mountains, dived into crushing ocean depths, and felt the power of storms and rivers. We've seen fire erupt from volcanoes and landscapes shaped over billions of years. Through all these extremes, life persists, adapts, and thrives against all odds. This journey reminds us of the planet's astonishing power, resilience, and the endless wonders it holds.